seeing each other for the next month, guys. That's the thing. You know?
Sure, we're not just not seeing each other for the rest of our lives.
You're right. We're the 4 best friends that we could ever ask for. There we go. Elaine, you can come too.
Oh, thank you.
You're welcome. Probably it's gonna get a little aggressive over here, I think, otherwise. It's gonna be Andrew energy, you know. Sorry. Not to make you into the mother of the situation
Oh,
here.
no, I would never be on it.
Good.
Don't worry about it.
I will then. I'll just think everybody slap each other.
Because I think that she was probably was in the rules so well.
Do little scams.
Yeah, I have 6 brothers. I will not be one.
Totally fine. Totally fine.
I totally know how to.
Oh, so
Well, you look like you already have the same kind of life.
kind of. So my question is like totally fine. Totally fine.
Totally.
That's fine, I would imagine, but it doesn't actually go to the webpage.
No, it won't go to the webpage.
Good. Okay, cool. That's just what I wanted to check. So I just want
No, it won't never go to the webpage. It's only going to go up and grab the data from the webpage and bring it in. You're not going to see anything that you're seeing all the time.
yeah, great, because that's kind of what I was trying to go here. Is that so just be, oh, well, if you're doing it, just like trying to like get like, you know, all the extra paths and everything like that, and then I'll be able to console log in and see, and then definitely just kind of connecting to the database and you can then hope that anyone else will see it.
Right.
Yeah.
So, okay, that's right. That's right. We'll do
Save the webpage.
and then we can bring the webpage and file, and then you can put the actual field where you log in. And you'll have the webpage where you're logging data. So you can just go to it and then print the file, and then start taking the application. Once everything's all fixed, so you got that data pack running, yeah. Drop it in there, it works.
Yeah. That makes sense.
I don't know.
It's the itself. It's the file path.
File path. When it goes on the file path, that's when that webpage, then knows what it is. Oh,
Okay. But I can also, like, when you train them, I can load the webpage.
Okay.
you could actually write
Hello, CareerDevs. All right. Everybody ready?
No.
Gotta get right now. Remember to prove where you are and it's proven yet. You don't fire them in some way. Good. Okay. Hello, CareerDevs. You're here 12. Yeah, that's me. Oh, cool. All right. Nice. Awesome. Okay. So, if you want, you can slide the chairs over if you want to see the board. So, Tuesday we had, of course, our algorithm for flipping pancakes. Did anyone actually make pancakes after trying this problem? Can you run them, or are they sick and tired of pancakes? Oh, that video is on, by the way, so be careful not to see the problem.
I forgot the video camera was there.
No worries. I just saw you going like right in front of it and don't say something. So, again, the main goal of this challenge was not for code, it was for approaching problems. Every problem we dealt with pretty much before this problem here has been a problem that if you wanted to, you could theoretically start coding right away. At least a little bit. You might have to stop a little bit and do some sort of testing, but in most cases, this is something you could jump right into. So this challenge was mainly meant to tell you to be impossible to do that. The second you read this, there was nothing you could write in it so that would make any sort of sense of, But let me put something down and get it to work, and let's keep playing with it via code, via syntax. So we can find the solution by just typing in enough code. The goal here was to start learning how to play with tools, how to investigate a problem, how to cut a problem up, pull it apart, find pieces. And of course, pattern recognition. This is how do I find the patterns? How do I find the way to solve these problems? What are some of the approaches I can take? You were partnered up with at least one person, as long as you were here, and goal to try and come up with something, anything. And what we're going to do today is actually let everybody come up and kind of just go over their findings. What were their findings? What were things they thought were interesting? Be able to share where their current path was, where they were shooting for, where they were going with, and what their current plan of attack might be, if they were to try to solve it at that moment. Essentially, when giving that kind of information with feedback, so when someone does if someone is up here making statements and stuff, do you think there's a good kind of follow-up question like, well, what about this? Did you think of this? Those are questions to ask at the end, because it can help that person or even yourself come with a more full picture. That's the idea here, to be able to work with each other to see if we can come up with a kind of an idea of global. No matter what, after everyone has presented, I will showcase to you one of the possible solutions, one of the patterns that I was able to find partially through just happenstance, and then I was able to confirm it. I'll tell you what I remember as being my train of thought. This was also 2017, so it was almost 2 years ago now. So it's a little not as fresh in my brain, the actual process I went through, step by step. So I'll do as much as I'll try to recall it as best I can. So for remembrance, just kind of going over quick what the problem was. We had the oversized pancake flipper problem. The oversized pancake flipper, the main idea is that we have a griddle that is flat and one-dimensional. In my mind, we can only have one row of pancakes, which that's not usually how it would go, but whatever. Because we also were given a giant pancake flipper that you can use to just flip the pancakes in place. This pancake flipper can flip a certain number of pancakes, no more, no less. You have to flip that many pancakes if you use it. According to the story, we did have a single pancake flipper, but our assistant, our lower level employee, who's probably not employed anymore, decided to take it to the bathroom with him. Never mind the sanitation concerns of that. Besides that part, he also took our spatula, made it very, very difficult, because then we were hit with a rush. I also don't know how long he was in the damn bathroom, or she was in the damn bathroom.
At least 100 test cases.
In a small case, yes. You probably realized what he was doing. He was just sitting there like, crap, I lost my job.
No, just the first part.
He panicked, shut down, he's like, can't do it. So, we had to use our pancake flipper, our giant pancake flipper, to flip the pancakes we had, and as quick as possible to make sure that the happy sides were up, so that they didn't burn, and two, our customers left happy and not bored from waiting for us, as they just see us in the back just doing this 15 different times, trying to get it to work. So, we do, as we were given with the test cases, we are given a number of pancakes and the current positioning that they're in, whether they are happy side up via a plus sign or a negative sign, or a negative symbol showing that they are face down. Our goal is to use the giant pancake flipper to flip them in the minimal number of turns to get them all face up, or determine that it is impossible to do that. Sound good? Of course, when you come up, you can give your own analysis as well. What did you come to understand the problem? If there's anything I left out, that's up to you. I'm just doing a quick synopsis. Melissa's actually watching from home, so I want to say hi, Melissa. Yeah.
Hey, Melissa.
So this whole
She's
video is
definitely
also going to be up there. She's named her. She's watching.
Melissa, slack us if you're watching.
Yeah, that's hilarious.
I will say you might be waiting about a minute. There's
Yeah.
slide.
No, everyone pull up your slack.
Yeah, I'll check it out.
Give her a minute. Get it.
That White Claw favorite.
Yeah, too many white claws.
Jesus.
That was real.
She's typing.
She's got claw thread. Oh, she smiled.
Got you, Brett. Prove me wrong.
Hard seltzer and all.
So now for the real challenge of this whole algorithm. Who wants to go first?
Brett.
Ah, he is.
Dan and I want to go first.
Do it. Dan's like, I do.
He's been going off on his own thing.
Well, then
We'll see
you
what he
both
came
gotta
up
do your
with.
own presentations too. So if you have anything different you want to talk about too, give it your own approach by all means.
I don't have it.
Yeah, you know, big O.
Big O.
So, if it's a divisible factor, if the number of negatives is a divisible factor of, or the total string, if k is a divisible factor, done, easy. But if you have floating happy faces in the middle of your pancake string, you have to analyze the pattern. So it means you have to ascribe value to each of the elements to differentiate them. So what I came up with 5 minutes ago,
Just before I get up.
if you analyze the position of the negatives minus the position of the positives that are stuck in between the negatives, and divide them by the size of your pancake flipper, you end up with a whole number, not a fraction. And I should be able to figure out if it's a whole number. Assuming this as well, this is for if your pancake flipper is an even integer. If it's an odd integer, or if it's an odd integer, you start at 0. If it's an even integer, you start at 1. It's worked so far.
I was gonna say how many tests have you done so far?
7 with
Has
different pancake flippers and different lengths
permutations.
of strings. But if you guys don't mind testing it out as well to find out, not solution based. That's
Definitely
what
a
I wanted to
solution
go
to try. So definitely something we can think of using afterwards. So that's awesome.
But
And we have a
otherwise,
possible
other
solution,
than this,
so.
just having to analyze each pattern and how it fits in. So taking k length of pancakes and comparing it to the other options of what k length matches up to, and checking that with a graphical.
Utilizing the data that you were given. Exactly. You're given K, you're
That's
given the
the other part.
S, and you can also get S dot length. So
So
That's
this
right.
will be in a loop or something like that? This formula will be in a loop or I mean position.
I've got that.
So you'd have to throw a loop to get all the mapping values or the index values.
Okay, so position minus, for example, you can show one.
Position if odd, position minus 1. If even, well, no, if odd, position. If even, position plus 1. If k is even. Because if k is even, you have to add 1 to each of these, just because
No,
of how I
just-
figured out it worked.
I was just thinking about how you can put the numbers in that position minus position plus and you can just run one test case. That is what I was just asking.
Oh,
She
in
was-
there, yeah.
she's asking if you could actually go through that one and
Go
actually
through,
show
yeah,
the
just
numbers.
Oh, this
one.
one. Okay.
Yeah.
Ah.
Actually do a demo for them of
Yeah.
your actual test of a test case.
So that's 8. So we know this I don't think works. So 8 minus, no, this one wouldn't work.
What's the rate for this?
What is 8?
8 is 1 plus 7. And so you would only analyze the positives in the middle, because the positives on the end you don't really care about.
Won't the
What-
five
what-
come in
what-
the
what is-
notification?
It's 8 positions. Can we have a size of the pancake flipper?
Oh yeah,
No,
this
not
one
yet.
was. Oh, what was? he didn't give that yet. But what was it?
Four.
This one might
This
not
is
work.
no. This one was a. This one was a fourth flipper.
Yeah.
But I didn't get
Yeah,
it
okay.
from where that 8 came and from where that 2
Because if pancake flipper is 1, it does. I mean, it would always.
Yeah,
work.
four
Everything
flipper.
always
Right.
works.
It's what
So
three
this
or
was the
four.
first example in the test cases
Okay.
that they gave.
Got it.
But that's the one that went to the bathroom.
Is the single one?
Yeah.
I thought it was like kind of like negative, and so it was actually kind of like just the other way around. You know, the pancake flipper just kind of moves. Yeah. You see what I'm saying? It's stupid. I'm wasting everyone's time.
Plus,
It can move in
That
any
makes
way
sense.
as long
Move the
as
handle around.
That's right.
Well, that's true.
How
You
is
only
that
have two
going?
things on that one
There you
page.
go.
Thank you, Miles.
I'm just flipping a
Okay.
board. That's
I get you.
I'm like not Euclidean with this stuff, you know.
18 minus 3 is 15, divisible by 3. All you do is
so what are these numbers? 3 from where that 3 has come?
this 3
No, yeah, that is fine, but first 3 plus 15 you are doing.
right at 3. The position of the plus.
The first position of the plus.
Yeah.
That is what you are
So you take the sum of the pluses that are in between any negatives.
Oh,
I didn't add the pluses on the ends. I don't know if that would help or hinder because
but your
I thought that
formula
was the
shows the
position
position
of
of minus.
what?
1 plus 2 is
Yeah,
3.
3. 1 plus 2, 3, 4, 5, 6 is 15.
Show it to the camera.
What?
Show it to the camera.
Oh. I got Melissa.
Wait. 1 plus 2
Can you
plus
repeat that one more
30.
time? Yeah.
1 plus 2 equals 3.
Yep, correct. And then 4, 5, 6
4,
equals
5,
15.
6, 15.
Okay. Minus the position of the positive integer.
All divisible by 2 or divisible by 3.
If it's a whole number, it works, is what you're saying.
Yeah.
Okay. Regardless of the size of the flipper, or it's because
If it's a whole number, I hope it works.
Okay.
Right now, it works.
Still
Right.
testing.
Okay.
Yes.
Is the idea.
So after every 3
How do we
numbers,
find
it's a
the plus?
positive. After every 3 negatives, it's a positive.
Not this. So this
Not
is
necessarily. This is just testing.
a sample
Oh,
case.
okay.
Yeah.
How do we do the one that actually works in the test case?
What is it?
It's minus, 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 plus, minus, plus, plus, minus.
Range
Hmm.
is 3.
Oh, okay, that's the same.
Case 3. Yep. That's the one I was expecting. Okay, cool. Let's check that.
So 3,
14.
7, 14.
8.
Joe, this is wrong. Come back to you.
It's divisible by 2, so therefore it's correct.
Divisible by 2, focus 3.
3.
Oh, the flipper's 4.
Nope,
You
in
get 14
this case
No,
again.
you
Three.
get 14.
In the first
This is
example,
14.
Hold on,
3,
hold
5,
on.
6 is 14.
That's Oh, also is that 14. what that means?
Yep.
So you get another The case if flipper's it's 0, 3. I think it's,
Case flipper.
I don't know.
yeah.
I mean, that's
They didn't put anything
undefined.
on it.
No, that's 0. It's
No, it's
yeah.
still 0.
It's 0.
Under is
Under is
under
undefined.
0.
Yeah.
DNA.
I
Um,
mean, technically 0 is divisible by 3.
So-
0 is 0.
It's not a fraction.
integer instead of whole number. I think.
There you go. So see, this is where we need more tests to see how do these work and what are the possible outcomes for this solution. Are whole numbers, are integers? What are valid solutions? Could you get a negative as a feedback? Possibly. Does that mean it's good? That's what we need to find out. So,
And of course, you
But-
still
I
need
like-
to know the width of the scrape of the spatula you do have.
which is always given.
Oh, it's always given.
Yeah. You always get the size. They're not telling you to use your flipper blindfolded.
Right. So this
You're
is
good.
just regardless of the flipper size. This is whether it's possible or not.
Whether to analyze.
Now, does this
Before
tell you?
going through
No,
the
this
process.
does not yet tell us how many flips it takes, right?
No. Well, yeah. 0 flips.
That's not
Oh.
Doesn't need any flips. Go into the bathroom with the other guy.
true. Yeah. They're both fine.
Run away.
No, it doesn't. It just says whether to go through and
Possibility.
analyze the rest.
Cool.
So
So this does tell you whether or not it's possible, which
Sorts.
definitely helps with a lot. This can definitely help a lot of the problems of making sure you're not wasting any sort of processing time to test. You can find out right away, should I spend any time flipping this, actually trying to get it in the right order, and that can save a lot of processing time. So good job
taking
there.
from this,
Yeah.
Yeah,
the
that's not
skeleton of it, whether it works or not, is
And then
there's
if
something
this
permutated of
if
that
this
would certainly work.
parallel is there, we could see how we can then tweak this to find out the flips then too.
And I can
So
help you
It's a
determine.
nice starting point. You found a nice, strong mathematical correlation that can be used for other things too.
This guy was my Mona Lisa inspiration right there. He worked on
Sounds
the
good.
connector for me.
And if it doesn't work, you may have determined an edge case like where it doesn't.
Exactly. It may be an edge case where you just need some sort of special scenario. So, if someone does find one that doesn't work, by the way, which so Evan just pointed out something really good. Do you want to?
Joe said.
Hello, CareerDevs. Evan actually just mentioned something really important here. So say that again.
Edge case.
Right.
Like when.
So if you do run this and you do find one that may not work, it doesn't mean that the item overall isn't good. It could be that that's an edge case where there's a special scenario going on. So if you can find where it doesn't actually work, where there's an inconsistency in the connection, figure out why that inconsistency is there, and see if it's something we can just create a special if scenario for it.
So that would be say if you did run it 100 times and say it ran perfectly fine up to 50, but then it failed the other 50 from 50 to 100.
Yeah, it is something that could be at least still viable, and you want to figure out why that 50th fail, and is that a special case scenario that this algorithm or mathematical formula does not work. It may not say that this formula is bad. It's just saying that there's certain special scenarios that it may not work right. And so always be aware of those. Edge cases are key.
For the 14 sample values, or like where are those numbers go from?
No, that's the
That's the
position
sum of the
indication.
minuses.
Oh, the
The sum of
summation.
the pluses.
Okay.
3, 5, and 6 plus 0, 1, 2, 4, and 2. That's 7.
What?
Oh, okay.
Very
it's,
nice.
summation
next?
of the positives and
Christian.
negatives.
No.
You and Joe, we get.
Christian's just gonna show.
You will go up eventually. So
We can
Besides-
start from there and then go like this.
Yeah.
Yeah.
Okay. We can go over here.
rip off the band-aid at some point.
I mean, we didn't get further than 40,
Yeah,
if
we-
that's what you want us to
I
say.
didn't even break
Again,
down the thing.
You want to give what you found. You may have found something different. There are several different solutions to this. So what patterns did you find? Is all you're looking over.
8 patterns. That's a lot.
See, there's tons of patterns in here.
But it still didn't solve the problem.
Whether or not exactly they may not be. Who knows which? The goal here is to find out which patterns exist, and as a team, try to figure out which patterns are relevant and which ones are not. There are tons of patterns. For example, what I was trying to show this morning with the students. Eraser. Stealing one.
Didn't help anyway. Yeah, I'm sure.
Given this, what sort of pattern do you see? Do you see a pattern here yet? Does a pattern exist on this?
Pattern of
What's the box?
What's that?
What's the box?
It's the shape.
Doubles.
You can count it as zeros and ones, circles and X's. I don't care. They're just symbols.
Yeah,
It
one
doubles.
Doubles, I mean. So 1, 1, 2, 2. What's coming next?
three.
Three.
Well, two
Or
more.
four.
No, it's going to be 1, 1
Two
again.
more boxes.
I see 1, 1 again.
You see 3, 3.
Two more
And that's
boxes.
the case. We don't actually have enough yet to really know what the specific pattern is. There are certain patterns that are going to pop out to you. A student in the morning class that they're going to see another square and 3 X's. This is the pattern they saw. 2 squares, 4 X's. They saw that the X's were increasing and they were surrounded by the boxes. That's what they saw.
Pattern starts further to the left.
But you're thinking that you could possibly just repeat the 1 X's. So X,
1x.
square, square, X, X, square. Do that, right?
Yeah.
That's possible. The pattern that was in my mind when I wrote this was what some of you actually did come up with. That this is then going to go 3, 3, then 4,
4.
4. That was the pattern I came up with. But you see how there are multiple patterns, but only one was a real one, and we don't know which one it is until we do more tests, until we go farther and we see more of the pattern. If I had then given you this much, we would have been able to eliminate some of the other patterns, right? The more the pattern we can see, the more the pattern that the one we're looking for, the better we can start finding that solution. And that's kind of the goal here. Everyone will come up. This is also practice for interviews. One of the things we actually got feedback from, a little bit of the feedback we got from the interviews that just occurred, was they wanted us to do bring back a little more whiteboarding. They themselves have brought back some whiteboarding, and they need us to bring some back as well. So being able to use the whiteboard, design, diagram stuff, and describe what you're doing on it is key for your interviews. So whether or not you have anything new to contribute or not, or you're not sure, it doesn't matter. You want to get used to this process of using whiteboards. They're going to be part of your interview process, so do not be afraid of them. So, I always shall ask again, who wants to go next? It doesn't have to be in any sort of order. It can be anyone at all.
Dan and I will go.
Yep. Oh, but like, names. That's you. Oh, if anyone can, bless you again. If anyone can monitor the Slack for messages from Melissa, that'd be great, because my computer is in use being recording, so if she asks any questions or anything she wants to add, she can throw it in Slack, and you guys can see it. Will it be a little, what's that?
Can't see the board very well.
I was worried about that. Not much I can do about it.
Just can't put it right in between those two. Right.
Oh, power. As I said, we want to make sure we are turning the whiteboard towards the video as much as we can. So, yeah, situations.
If pancake.
Eat all pancakes.
If pancake, not flapjack.
You don't want to face down.
Yeah. No, just throw those kind of ones in the bathroom. What to do.
There's only cook from one side.
Buy another grill. Put the grill on top.
That's the
Panini press pancakes.
Someone's in this down. Chuck their skin on the side.
Yeah, make both sides and behind me. Yeah. It's gonna cost my section of chocolate chips.
Get them from the bathroom. Everything's in the bathroom. If pancake, go to the bathroom.
Sterilize the spatula.
Sterilize.
No, sterilize the employee.
Yeah.
So she's thinking of this like in the world.
I don't know if it works though.
That's still a problem.
Why? I believe you.
Still probably you still have to put it, you go back to that page again.
Oh, down to list.
You can just put this list, you can put it in some container. You can put it in an array, you can put it in
List makes sense because you want to just have it be the most large.
Yeah, I'm saying you can put it to carry it. I run it through an array. But that should be handy to do. No, it's just gonna be for each, just do.
For each cable standard.
For each bar.
Oh, right, bar row.
And then your table there.
Alright, let's check it out.
Let's watch it explode.
My computer is starting to smoke slowly.
You know, if you just run it, you can just push the stop button, or automatically build it, or whatever, so it's like fully built. But, I mean,
You ever seen like, you know, like when baseball players like just do the same thing in between?
That's all I do. Just saving stuff, I used to do that all the time, I'd save it and stuff, and it's just good habits.
So it's obviously taking a long time to go to this website.
That's right.
Well, I have to do this one eventually, right?
Oh, I thought you would have to do the,
Yeah, I think you can do whichever one you want. It's just like it's just right there. Yeah, you can. No.
Yes, you're gonna get a lot of that. A lot of that. That's what I'm saying, go to the easy page, it works.
Well, yeah, but you don't.
Yeah, you
No,
can
I'm saying,
things
go
that I
to
say
the,
about
just
that.
run
So
that,
this is pretty
just run
straightforward.
the yellow
If
pages.
all of them are minus
It
and
works, you're like, okay, it works.
the pancake length is equal to the range, then one flip, just flips all of them so it's possible. If all of them are plus, do nothing. If all of them are minus and the number of minuses modulo range is 0, then the divisor is the number of flips that you have to do. Yeah, and that's a possible case.
The other question is, that's an AX page.
If there's overlapping sequence of pluses and minuses, then it can't be solved in any way. And if there's one minus in your entire string, then any way you flip it, you'll eventually come back to the original pattern. So you can't solve that either. If you have one plus and rest are minuses, the number of minus
I see right there.
modulo range
What's up?
gives you 1. That's not possible either.
This is a problem. This is the problem.
This one is if pancake length is a multiple of the range and the number of pluses and minuses are equally distributed and the pancake length is greater than the range,
Oh, iteration.
then it can be flipped and the number of flips is equal to the range.
You can do iteration.
And this is a mirror image
This is
condition.
still a problem.
If you have number of minuses greater than number of pluses and their difference modulo 2 is 0, then the number of flips is equal to the range.
Can you explain your first impossible scenario?
Word.
If the range is 3 and this is the string that you have,
What else say?
so only things that you do. And you have a minus plus that's common to both of these substrings or subpatterns.
That's what I like to use with overlap. They overlap where the two items, where the items inside of our pose are all the same.
It's just
There's no way for them to be disconnected. You can't detach those pieces.
For the second one, if you do plus, 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 minus, and the range is 3,
Range of wireless.
plus, minus, minus, plus, minus,
How you do
plus,
a file.
plus, 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 minus, minus.
Not that one.
Yeah, you have one left, but here, I have this in my library.
Plus minus one. Yeah, so I see what you're saying.
Yeah, so you come back to this.
Yeah.
And
That's what it's management file.
for the third one,
Data out.
I don't have examples, I did it all over the
Fine.
place. So
What we're seeing is that you're definitely coming with a lot of individual specific scenarios that are, slowly
I don't
winning.
agree with this one. If you have plus, minus, minus, plus, plus, minus, and the range is 3, this is basically sort of a mirror image of
And
this.
then you have to iterate through it, and then
You
you can
can
stream
do
rate a rate line,
plus,
and then do that,
plus,
and
plus,
close this up, and then close the file, rest out.
Alright,
plus,
that makes sense.
plus,
Yeah.
minus,
So I got more than three.
Well, yeah, you gotta do that.
plus, 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 minus, minus, minus.
Alright, that's fine.
But you can do this though, you can do
Yeah.
it on.
How,
So the good thing is you do this this was to figure out, are any of these able to justify others? Because otherwise it can be a very massive decision tree.
Yeah.
And that's not very efficient. So one of the big things we can do is figure out if any of the possibles or even impossibles can justify each other, or if there's a certain process or flow we can use to test for multiple. We can follow a certain pattern or process that can combine some of these possibles and impossibles. Otherwise, we have a very fairly decent tree we're going to have to create out of if statements and flows to check those things. So, what I like about it is there's a lot here.
Trying to find this
Very
way you
possible
can
to solve a lot of problems. So, very good on that. And these are those things. All these possibilities can give you ways of trying to approach the problem. How do we? And what I would say is using these items, validate your test cases. So, create test cases and try to validate. How to combine simpler ways to confirm these items. Now we know we can, with this system, we create the layout right away. We just figure out right away, is this possible, is this impossible? Well, now that I know it's possible, what can I do to then prove that it's possible? Well, I know this is impossible. Can I do it quicker? So now that we want these scenarios, you guys as a human now in physical form, in physical realm, we're on the whiteboard with plus and minuses. You can now create your examples very quickly, know right from the get-go if it's possible or impossible. So you have a test case with a expected outcome. Now you start finding out what's the process and steps to then validate these. So that's what I like about these. Is you have your test cases and coming up with your process a lot easier. Because you know already, is this possible or impossible? One of the biggest things I had to deal with actually was nice to have some of these was I was just sometimes flipping whatever I had in my example, like coins at the time. I would flip them for like 5 minutes to realize, okay, yeah, this is impossible, I can't do it. And if I could have known earlier that it wasn't possible, then I could be like, okay, well, just looking at it without doing any flips, can I find a way to prove that this is impossible? Or can I figure out a certain number of flips that tells me this is impossible? So, question. So that was kind of like, that's what I like about these, that this can help us to really pin down a steps to then validate these quicker. That seems that's what your next task would be.
I'm using a different with this app.
Or how you share these if you want them in a
What's your watch list?
chat or something like that. Chat or something.
Yep.
That's the link for that.
That's the link for the stock data that I'm gonna, the stock data that I'm gonna parse.
That's the web page.
How many stocks do you got?
Ooh, it's like each one of them.
I didn't see it, I heard you, but I didn't see it. I was like, wow, that's good.
All right. All yours.
Where's
So,
this
like, mine was-
That's an HTML agility pack. Think of like when we did it.
Test case,
Oh, so that's how it is? That's
Brain.
that's the brain.
positive roll,
And then that's just my very
and the range.
scraping event. Document.
Alright, test case number 2.
Don't forget you have the camera on this side.
And then
Now you have to insert this.
I know what I'm saying. Just don't forget that it's there. So once in a
but
while.
that's actually a very similar process to think of that
So-
we did before. Like you just grab the data from the console.
Well, you pretty much just did Facebook,
So,
but you didn't
test
log in.
case,
Well, you did log in. It's already logged
It's
in.
already logged in.
test case number 2.
So you have to be logged in first. And then
Items in the
I
string.
don't think that's true for the HTML scraper. But you
There are
could
3 positives,
because if you just integrate Selenium
and the
into
range is
you
3.
can do both Selenium and Chrome drivers. Yeah, exactly. I mean, I'm just doing
Test
this.
case
I'm
number
confused.
3.
So how do you already get all the stocks
That's
that you
5.
grabbed, obviously?
Mhm.
Weren't just because you can't log in with HTML.
5 positives.
So you already logged in.
I just chose a table you didn't need to log into.
Oh,
I just chose a different
okay, that
table.
makes sense.
4.
So but if I was using the Yahoo thing, I basically just keep my login
I'll turn it
process
up
from
to
before.
I'm going to use
Yep.
Google
5.
Finance. So I'm going to use that book. I like that process. It's very short.
4.
Too.
Super short. I mean, it's really short.
And then I jumped to
So you
6
can think about it
because
this way. So it's
number
like,
5 was
if I wanted to,
self-explanatory.
right, like I would just do what got
I don't know,
me.
the problem is you got that thing in a big list.
And 3.
Well, you sorted the list, right?
You've
Test
got
case
list
7
now,
has a
right?
9.
Short.
Okay, so how are you gonna separate that, are you gonna separate the symbols, but
The impossible one
to
is right
put,
here.
put each individual cell in the data?
As
It wasn't
long
something before you
as
could just grab like columns.
this number, the positive,
You can still do,
is
you
equal
I
to
can
or
still
greater
do that
than the
if I want
range.
to.
can, because
It'll pass.
I did do that with the HTML.
As long
I
as
grab the columns.
the positive
The columns
is
gonna be the answer.
greater than the range,
I don't know,
it'll
you pass.
pass. If the
I'm gonna-
positive is less,
That's
Look around.
right.
But, you
this
know,
will pass,
best in this best.
Yeah. I'm sure it's
So this is what you
done, so I'm sure it's not impossible.
No, it's not impossible. It's just it's got.
I haven't tested it all the way down the string, but that's what I'm looking for.
You should
range is a number
And
of
then
flips.
It's okay.
Your spatula, your whatever thing is.
It's not the width of the spatula.
The width of the spatula.
It's okay.
K,
Sorry.
K.
Okay, so if your range was 4, you had full, you had 8 items in the string, and you had 0 pluses.
You're just pulling the X pass. You're just pulling
Say
the
again?
X pass of the actual.
If you had no pluses,
Probably the letters doesn't matter. Right, because.
I haven't gotten that
each of
far.
so
those-
you have two
It's
flips.
really similar to what we did in the,
4 and 4.
in the Selenium.
I didn't get that far.
Okay.
But as far, I got to 7. And
And
I
of course,
came
yes,
up with this. And I see the
When
pattern
you're
here
data model,
of 3 to
you've got, I
3
mean,
to
it's
5
really, really
to
similar
4. As long as
what-
it's greater
and I just kind of
or
want to
equal
like
to, it will pass.
It's really
Because that's
similar
what
to what
kept happening except for number 4.
I did before. I'm trying not to look at.
That's what I
There's
found.
definitely more to it.
That's what we saw so far.
Here's what you're pointing out. There's some other additional edge cases and situations that can arise, but nice find. That there's definitely a correlation between the plus and the size of the flipper. That
So it's not really it's the pluses and the side of the
Really, there was a correlation between if there's a lot of negatives, the best you can do is get it to be all face down, potentially not all face up. So there was one of those situations that I ran into a lot. And one of the things that's very clear on this one, make sure it's very clear, is just because if you're in a test scenario and you can get all the pancakes face down does not mean that they can go face up.
Right.
Now, yes, if you had the original layout and you inversed it, that one could actually work. That one can get all face up now. But just because you can get face down does not mean it's like, oh, well, I can get them all face down. I gotta get them all face up. That means one of the things I had to get through my head for in the beginning too. I was like, oh, I got it all face down. There's got to be a way to get them all face up, and I would spend almost minutes on some of these items trying to prove myself, which was impossible. All right, next.
Does that make sense to anybody else?
Come on, Christian. Go. Come on, you two. Let's do it.
True.
Okay.
Come on, Joey will do it.
Just write dev connector really big. So we're introducing a new project today.
Yeah, there you go.
I'll be the eraser.
Same thing here again. Joe didn't admit that he I solved it. He's like, this is something I found. Is he confident that it's a thing that's going to be really helpful? No, but it's still something that you found, and that's key. Those are, as long as you found something that can then be investigated deeper, that's how science works. Science is about finding theories, finding hypotheses, and then having them tested by others and confirmed or denied.
Presenting a newspaper.
I know, right?
Right.
Oh my god. Joe, did you find
So like you saw I was writing stuff on the whiteboard, but I didn't save anything from the whiteboard. I know that I did have that one formula that we showed to you, but I don't think it's over encompassing or anything.
That's just it. Showcase
I
your
don't even remember it.
Why would you save it?
Like every time
I told you guys to
It's just the
review it.
whiteboard, yeah.
I was just doing like too much in the way of like I'm really good at being stuck in mountains. So I kept trying to use modulo, and it was like
Yeah, modulo K, right?
if K, I can't write
We lost our cap.
Joe, if you love
No cap,
modulo so
no.
much, why don't you marry it?
He always talks about
A nested list, so it's,
Modulo is powerful. It's one of those tools we tend to forget a lot of times.
I mean, mine was
and
modulo.
it's, so that means it's a list of
There's-
the
I didn't see
headers
any
within the
modules.
list of the rows.
Here's if you wrote out wondering.
Let me make sure you remember.
Oh, I'm sorry, that's mine. I'm sorry.
Right. You were in the background pollution.
It's just 2 Irish guys talking. Sorry.
just getting small birthday. But yeah, so like this was something I had like I was trying to come up with as I went, and it was like if K is even and the string length is odd and the count of the minus minus the count of the plus equals 1 and K is greater than 2.
Back to counts of them, I like it. Alright.
Like and then like I don't know, that broke at some point, and then I went to like if the count of the minus modulo K isn't 0, it's impossible. But then obviously the first test case breaks that. So It was just a mess. A whole mess.
Well, again, even reviewing the items that failed to prove can help people to avoid those pitfalls too. So remember, we don't have the logo here yet. Remember the light bulb. When the guy was trying to come up with the best filament for the light bulb, how many permutations did he try before he found one that was actually decent enough to say this is a light bulb?
K times.
100. He had 100 different permutations of metal components and mixtures to find the right filament for a light bulb that he would say that this is good enough for a light bulb. It was still not the best light bulb out there. The thing still didn't last very long, but he felt it was good enough to be considered a light bulb that lasted long enough, gave enough light as well. It didn't burn out within a certain amount of time, and that it gave enough actual luminescence. The guy put in 100 different permutations and never once gave up. 100 times he was wrong. It was incorrect, but he never saw it as being wrong. He saw it, and the way he worded it was, I have ruled out another combination. I know this combination doesn't work, I will never test this combination again, and no one will ever try this combination themselves. I have ruled it out. I have saved people from making this light bulb, this non-light bulb. And that's the way you can look at failures. The failures when solving a problem is not entirely a failure. You are ruling out a possibility. That's the way you need to look at it. So when you're doing things like this, what you're doing by showing people like, hey, I attempted this, it did not work, don't do it. Is what you're really telling them. Is like, don't go down my path. And that helps people.
Down my path.
It helps the group as a collective. It helps people to figure out and get closer to the problem. By also eliminating potential pitfalls, people then have less pitfalls to fall down and can find the newer, the more correct path a lot easier. If you're in a giant maze and you have somebody who's writing down X's of don't go down this way, your path through the maze is going to be a lot easier. You're going to hit a lot less walls yourself, and it's going to allow you to hit that endpoint a lot sooner than if you had to do it all yourself with no one else previously going in first.
So right, it's your file.
Did the person who went in first give up half part of the way there? Yeah. They're like, you know what, I've done enough X's, I hit enough walls, I give up. But at least by sharing that knowledge, the next people that come forward are going to be able to potentially get there sooner. They're going to get farther than you did. And that's why the sharing of knowledge is very, very powerful and not diminishing what you've done, even if it doesn't actually bring us close to the solution. It does bring us closer to the solution. Sound good? Make sense? So don't beat yourself up over, this one didn't work. Nope, this one didn't work. Nope, this one didn't work. I came up with probably 10 different ways of trying to solve this that didn't work. And then I finally got the one. I'm like, why didn't I see this in the beginning? So.
Bragging over, we only took 10.
10 full complex systems.
Yeah, and you can
Just because I couldn't come close to phone.
switch.
And then Brett. I tested this one 10 times.
Fine.
Yeah, I know you did say that.
Right.
So, for the record, so that everybody's clear, I did the oversized pancake flipper, the toy numbers, and bathroom stalls problems.
What?
So, for this year, on the qualification round, this is 2017, this is one I actually attempted myself. It was a full weekend to do it. I solved the problems A, B, and C. Those are the problems I was actually able to successfully solve. I actually looked at D and couldn't figure out even where to start. I had to involve graph theory, and my knowledge of graph theory is very, very low at the time. Grids. I was not very strong with grids yet. So I didn't even try because I had gotten the points I needed to qualify by that anyway. There were 65,000 registrants for that year, over 65,000. 25,000 people at least submitted one successful data set of one of the four problems. Based on, so if you take a small data set and you submit it and it's wrong, you get a 4-minute penalty added to your time. Other than that, you are scored on the points as well as how quickly you got it as well. So points first, time second. Your time is how you then rank with those who got the same number of points as you. Out of the 25,000 people, I ranked just under 4,000 with a score of about 20 hours. With my penalties were, I think I got 5 penalties, so about 20 minutes only of penalty time. But I still spent over 19 hours working on these, 30. So, 19 hours of actually working on it. To be aware, these were not easy for me either, so I had to go through a lot to figure these out, but I was determined, and the goal is getting good at just always making forward progress. Trying something, taking each failure as a step forward. Sound good? So if you want to look at it when you're on there, if you go to the scoreboard, I am under Cliff C. That was my name on the system. That was what I was registered under. You can actually find me on the dashboard of 6 passing through the qualification round. And you can don't know if you can actually see my attempts, but you can see that I tried what I did. And it'll tell you how many times I had a failed attempt and how many times I tried each one. So tell you how many wrong attempts I had. So anyway, there's that. I think we have 2 people that are still needing to tell us, Keith and Brashali. 2 people to talk about what they reviewed over the week. Marker and eraser on the chat.
I didn't come up with any formula or anything.
Anything interesting? Or how did you approach it? What was your approach for it?
Like, I just considered that this is a kind of array kind of thing. So starting from this point, and then the number of the range of the or whatever k value of k. So I just started. Whenever you hit, you are going to suppose a for loop. Also. Whenever you hit minus, then you leave those things. So this will be plus minus minus. So like that, you go in each loop, flipping those things, and kind of means you are pushing this minus towards the end. And at the end, if you see the pattern like in binary we say 0, 0, 1, 0, 1, 0 up to 1, 1, 0. So these 3 conditions, this is for the range k equal to 3. So for these conditions it is okay. These 2 conditions okay. But if you meet any of these conditions, like 0 for minus and 1 for plus, so that means you cannot do it. So that is impossible case. And you can just break and say that it is impossible.
Yep.
So it is just sequentially going.
You're in an interesting you're on a very interesting path. You're gonna find out. So yes.
I actually did the same thing, but then I was like, this isn't helping me find the minimum, so it's really
Yeah, it will take time.
You're not sure. You're not sure. Can this find the minimum? It's one of those questions where you're like, does this find the minimum? Is this the fastest this way of doing it? And it's not. You're not sure about that. And that's one of those things that's interesting about this is that at first, that can look like, well, is that going to give me the minimum? We'll talk about that in a second. So. And Keith, you come up with anything interesting?
No, I mean I have a lot of trouble with this assignment, so I didn't really have anything. My mindset was to count the number of pluses and minuses. After that, I didn't have anything else.
All right. Cool. Yeah, a lot here. The main thing is just keep trying things, keep playing with it. That was what I really ended up doing a lot. I wrote so many different things. I wish I could actually find the notebook I used too. I actually had a notebook as well as whiteboards. This situation to figure it out. So for me, I came up with there's a lot of scenarios I worked with. I definitely worked with like counting the pluses, counting the minuses, looking for that, flipping randomly to see if I could find something that made sense to me. What I realized is that the flipping randomly, like first what I tried to do is when I saw those items, like the very first one they gave us was, when we back to first statistic scan.
Negative, negative, negative.
Yep.
Plus negatives. Plus negatives.
And it has the flipper of 3. So I was looking at this, I liked how they were able to very quickly, well, they identified this, and so they flipped that, and they were able to realize, oh, if I flip this one, I can get another 3. Like, oh, can I look for those types of things? Can I look for can I have my system scan for easy flips that'll give me the flips that I want? But I was like, how do I do that? There's so many different variations of that. How can I determine that kind of situation? It's not going to be viable. I wanted something that was less me jumping around the system and more of a iteration system. And the iteration was my key. And so what I had to figure out was a couple things. One, can I figure out is there any sort of mathematical way of figuring out what the minimum should be? I can't remember how I figured it out exactly. But what I realized was that based on the length of the number of pancakes and the size on paddle, that actually can tell you what your possible best case scenario is. It'll tell you what your best case is, and if you can't even do it. For example, in this case, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 items, and a flipper of 3. What I was able to figure out is that if I can't, like going through a pattern, if I can't get this 5 flips, then I've wasted my time. It's too much. And with 5 flips, I should probably be back where I started, depending on how I flip things. So So it was one of those things I found. I think I used the impossibles to realize that. It was the impossibles that helped me to realize that if I go above length of stack minus the length of the k, that if I go above that number, I'm just going in circles. That's what helped me to realize that. This doesn't tell me what the best flipping case is. We know that 5 is not the answer. But what it can tell me now, if I do find a system that allows me to go through here and that I know that it will find the minimum no matter what, I can also realize, oh, if I don't solve it, it's going to, nope,
Well,
it's not
it
solved.
doesn't exist in the current context because these are coming through this.
What I really wanted to do is realize, oh no, that was what that was. What this gave me was, how many unique flips can I do? How many unique flips can I do here? Well, there's 1, 2, 3, 4, and 5.
I got my,
We pull these actually down. I'll pull them down. So we that. So minus, 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 plus, plus, oh no, minus, plus, plus, minus. Right? That one. So there's the 3 here. And there's the 1, 2, 3. There's the 1 plus minus. There's the plus minus plus.
Minus plus plus.
I heard something
when I
the
was
same.
bleeding, I didn't know
Plus, plus,
I'm just
1, 2, 3, 4, 5, 6. Not that one. 8 minus the range plus 1 is what it was. That's how many unique items I could flip. And so using that, I was able to say, okay, I can go to solve this without any flips.
How did you find out unique number?
What's that?
Unique number of
The length of the item minus the length of the flips. It would tell us how many unique systems plus 1.
Where's my success?
Did you just flip in the middle, or
What's that?
will like a middle flip be a different combination, or like flipping a?
The middle flip is right in the middle.
Okay.
This is all 6 scenarios of different segments I can flip. 1, 2, 3, 4, 5, 6 segments. Even on the impossible, which was plus minus plus, right?
Plus minus plus
That one, right?
minus plus
Oh, it was the other way around.
Minus, minus, plus, minus, minus.
minus plus minus plus minus.
Right, that one, right? That was the impossible they gave us?
Minus plus minus plus minus.
Yeah,
Minus plus minus.
Plus minus.
Okay, I just had it reversed.
And the
Okay.
range is 4.
And the flipper was 4.
Good.
So this tells us, so let's see. So we got 1, 2, 3, 4, 5. 5 minus 4 gives us 1 plus 1 gives us 2. How many unique flips are there?
2.
2 unique flips. Does match up? I was able to determine the number of unique flips I could have. And I was like, so I wonder if I can forcing myself to do no more than that and potentially only flipping each one of those sets once. Could I figure it out? I wanted something that I could repeat. So I took a shot and did similar to what Charlie did. So let me go ahead and start from the right and just flip if I see a minus. If I see a minus, I'll flip. And then based on the new change, if I see a new minus, I will flip again. In this case, I flip. So I saw the minus here, so I flip these 3. I then go from this way, I see the minus here. So I flip that one. So
I feel good about getting
4 plus minus minus minus.
At least I know my part.
And then I go left one more time, and I see another minus, and I flip that, and I got the right answer. Didn't I? Like, oh, I saw 3. So we'll do the same thing with the impossible. 4. I see a minus. I'll go ahead and flip them. And with plus minus plus minus minus. I see the next one here. I flip those. And the question is, do I know if I'm impossible yet? Based on this, can I confirm if I am or I am not impossible? Without already knowing that it is. Just by looking at that now, can I tell that it's impossible? Yeah, I already figured out. I'm like, no, I can look at that right now. And I tested it a couple times, I'm sure, but after doing those 2 flips and realizing there's still a minus there, I'm like, you know what, that's impossible. So I kept testing this. I'm just going right to left one time. Anytime I hit a minus, I flip that. I do a flip, and if I get to the end, I can't make any more flips. I get to the end. There's no more minuses that I see. If there's still a minus left over, it's impossible. It worked. It actually worked. Based on how the algorithm, how the flipper works, the main key there is just, the bubbling over of the minuses. If we can bring over the minuses over, and the bubble, I started recognizing, I started seeing them in the larger ones that I started creating. Like I actually got to the point where I was like, I didn't believe it. I actually did like a 20 size stack or 25 size stack with a 4 flipper, and what I noticed was, I was bubbling the minuses from the right to the left to try to get a single flip of 4, or to get them all, at some point to get a single flip where it had all the minuses in it. And that flips it over, and they all become positive. That's what I was attempting to do. Group all the minuses together, clump them together, and then flip it. And if I couldn't do that in an efficient fashion, it can be done. But there was no way to get all the minuses in a safe area to flip. Couldn't be done. So the algorithm is very simply from 0 up to length minus k. If you see a 1, flip it. And you did have to get a function to actually physically flip the items. So I could actually then go back again. So I had to do some checks and keep going until I get to the end. At the end, I would then see if there was a minus somewhere in the list. If there was, impossible. If there wasn't, return the number of flips I did. Fairly simple code, surprisingly, once I found it.
Can we see what the code looks like?
I have it in Ruby.
Yeah.
I can send it in Ruby, definitely, but what I would like to say is, based on that, so,
Did you keep it
based
as
on
a
that
string?
knowledge. What's that?
You kept it as a string the whole time?
Yes.
Yeah.
Yeah, that's correct, yeah. Could I have done a conversion to like numbers? I could have, but I didn't see Yeah, the issue would actually just be the importing the standard in. That's what I'm working on now. Trying to understand how to use readline. So, if I can figure out how to use readline, I'm good. That's all I got to figure out. But yeah, the code is not too difficult. Again, it's simply, you have a flipper. This takes the start point. What was it again? The start point. I was setting the stack, or the array, start point, and I think the size of the flipper, if I remember correctly. The size of the flipper. The stack, second flipper, I would get a function like that, and then it would say from the start point up to start plus flipper, iterate through those pieces. So if I was here, these are already done. So in this case, I would say from this point to my start would have been 0, 1, 2, 3, 4. From 4 up to 4 plus flipper, which would have been 4, 5, 6, 7, less than that. So we do 4, 5, 6. Take the minus, plus, plus turns to minus. So I had a flipper, a flip function, or method if you want to call it, for object oriented. And all I did, I iterated through the item from start from 0 up till less than size minus flipper. Size minus k. And then at the very end, I just did an include because Ruby has an includes as well. So JavaScript has includes, Ruby has includes. So you can play What's that?
What was the end index? You said my size minus.
The end for my system would have been.
No, just the grid has some condition, right?
Oh, condition
What
was.
was the last index?
The last index was length minus flipper. But once I get to here, once I get to this guy right here, if there's still a minus, I can't flip here because it's only 2. I only have 3, so I want to I get that last one of the flipper size, but then I don't need to check anymore. Once I have less than the flipper available, no need to check it. Because I can't do k minus whatever.
Like every single push that we did with BSPU is like 5 commits.
The solution is fairly straightforward and simple. the key for this, finding this again, was the idea of iteration of computation trying to solve it. And unfortunately, yes, as much as I pushed to be doing things in person, the goal was to prevent yourself from doing the human thing of jumping around. And it's hard for us to break that, and that's why I like this one so much. The reason for this one is to start getting us to remember, computers can't do that. One of the biggest exercises for this are these. I'm going to show this on the camera here, but what you want to make sure you avoided working with this was the idea of just jumping into the middle and flipping from the end. Be like, I'm going to just jump around like a human would to see if I can figure it out. A computer isn't known to jump around in the systems. They follow left or right, they go down the path, they add information, and then based on that, they make decisions. But there is that process of going from left to right, or right to left, where there's this step-by-step flow that we definitely need to remember about computational science to make sure, yeah, on one hand, if it's okay to do the human way, to kind of test things, to test theories, but you do have to find a way to break it down to a very simple step-by-step flow that you can repeat easily. And that's what I had to do, and that's when I stopped the jump around method and started trying to do these, all right, I'm going to go right to left, or left to right, or using the digits to see if I can find some patterns. That's when the items actually started really popping at me. When I finally started to find some patterns. So those sort of things like these less thans and stuff, and I figured out my iterations of what items we could go through, how many unique items there were, and flipping those, I saw the bubble sort, which is one of the downsides.
I did say it's a sorting.
Yeah, it's really what it's trying to do. It definitely has a connection, or it's related to the bubble sort.
In the first case, they kind of throw you off because they jump around. They show the left and then they do the right and the middle. Yeah. So you kind of don't think that. You shy away from that.
They definitely seed you to start doing the jump around. All you had to do in that test case to really see it was to not follow their example and do it and try to solve it in a more computational way, and you would have started seeing the patterns right there. So they purposely did that to mislead you. I can guarantee it. Do I know for sure they did that? No. Do I feel like they did? Totally. It was like, I'm very confident it was done intentionally to keep you from seeing the bubble sort of mechanisms go. The thing is that if you did actually do it like that and you didn't get hit by their seeding, it was very quick to solve. In this one, they did comment that the person who submitted the very first successful data set took him less than 2 minutes to submit a working data set. Probably on this, because he probably looked at it,
Just saw it.
did the thing and like quickly saw the bubble sort. But yeah, I don't know which one specifically, but I'm assuming this one, because yeah, if you are very familiar with sorting systems, you probably, when you looked at test case 1, he probably instantly saw the bubble sort mechanisms going and had a bubble sort system already there that he just had to speak. Instead of, didn't even have to create it from scratch, but already had a semi-built bubble sort that he was able to use and modify. Yeah, you can use any language you want, and you can use pre-built code as long as it's open source, as long as it's public. So frameworks are fine, things like that. Whatever you need to use is fine as long as it's open source and public. There's no restrictions. You have to send your solutions to Google, and they have to be allowed to use it and publish them. So they have to be open source and available to the public. As long as it is, you can use anything you want to solve. Sound good? So now you know this, that the algorithm is not that complicated and over complex. Try to write the code now. So what I would say, if you want in your teams again, if you have your teammate here, if you don't find someone who didn't have a teammate as well, 1, 2, 3, 4, 5, 6, 7, there's 7 of us here. So if you want to do 1, 2, 3 at least. I have Christian's here too, so yeah, good enough. So teams of 2 again. Find a partner. You can do the same partner you did yesterday on Tuesday, or find another one. I always recommend to find a partner you have not yet worked with. So if you worked with them on this kind of stuff before, do not do that. Mainly the goal for this is, anytime we do a team thing, is to make sure you're dealing with everyone in your class and you're getting different experiences and exposure to different points of view. You don't want to kind of get stuck in always working with the same person, giving always the same point of view. The goal is to explain your point of view. So find someone to partner with, and work the pseudocode if you want. So you can then code it over the weekend. As we challenge the weekend, we will start the next one on Monday. So Monday will be the next Google Code Jam challenge. So for the weekend, your goal is to kind of see if you can complete the code for this. Again, spend no more than 1 to 2 hours this weekend on this item. I recommend.
For coding,
What's that?
for coding,
With this.
coding, yeah.
Yeah, with this problem alone. I do not recommend spending more than 2 hours unless you're close to solving it and you're like, you know what, a couple more minutes won't kill. If you feel like if you do feel like it's gonna benefit you, you of course make the final call. But if you're spending way too much time on this and you're not working on your other stuff, that's gonna hurt you in the long run possibly.
Yeah.
Could. Remember, your def connectors and your C getting through def connectors and getting to C# is your priority. So I recommend that. It's your next step in the class. So again, no more than really 2 hours working on the actual code for this. What I'm going to do is right now, well, we're going to work on this. I'm going to work on the read line system for JavaScript, and I'll be able to share that out. So you'll have a program that you'll have a skeletal framework that can accept the input from Google Code Jam. So when you create your function, that main will call, that you can call using main. You can actually try to run these test cases through your system and see if it works. All good? Alright. That's it, Melissa. All good. Have at it. Bye. Say bye, Melissa. Or not. They all waved, even though I didn't have the camera facing them. Yeah. Okay.